you the common error, let's explore this expression a little bit, which is x squared in the numerator and x squared minus 4 in the denominator. So what if x equals 3? So if x equals 3, in this expression, I will have 3 squared in the numerator, and then I'll have 3 squared minus 4 in the denominator, and that will be 9, and then 9 minus 4 is 5, isn't it? So if x equals 3, this will be 9/5. Well, what if x equals 1? Well, then I'll have 1 squared in the numerator and 1 squared minus 4 in the denominator, and that'll be 1 all over -3, or -1/3. So let me rewrite this expression here, and I'll tell you the mistake, or I'll show you the mistake I see all the time. I see students say, oh, there's an x squared in the numerator, and there's an x squared in the denominator, so I'm going to cancel them, and that's going to give me 1 over -4, or something like that. Well, that cannot be correct, because you've got to take into consideration x is a variable. It could be all kinds of things. So the mistake here is incorrect cancellation. I actually hate cancelling. Don't cancel. What you're looking for is a factor of 1. So what are the factors in the numerator? Well, they're x and x. And what are the factors in the denominator? Well, that would be x minus 2 and x plus 2 are the factors of x squared minus 4. And there are no factors in common. There is no way to cancel anything here. What if instead I had x cubed in the numerator and x squared minus 4x in the denominator? Well, now I am going to be able to find a common factor. X squared minus 4x in the denominator, so x cubed is going to be x times x squared, and I'm in the numerator, and I'm going to be able to factor an x out of the denominator, so that's going to give me x minus 4, and here's how you need to think about cancelling. You never, ever are cancelling. You are looking for a factor of 1 that multiplies something or other, and here, this is x over x. That's a factor of 1. Then I can, quote, cancel. It isn't really cancelling. What I'm doing is I'm noticing that this is just 1 multiplied by x squared all over x minus 4. So, and 1 times anything is just that thing again. So obviously here I have x squared all over x minus 4, and I'm not making the mistake of trying to cancel unlike terms. I'm looking for a factor of 1, which I did not have before, but I do have now. Like terms have the same variable and the same exponent. So you are seeking the same factor in the numerator and also in the denominator. This then will give you a quantity multiplied by 1. It looks like cancelling, but it isn't, is it? Another very common error that I see is the incorrect binomial expansion error. This does not equal x plus 3. So let's explore that a little bit. If x equals 1, because x can be anything, then I have the square root of 10. And the square root of 10 certainly does not equal 4, does it? Which is 1 plus 3. If x is 2, then I would have 4 plus 9, so the square root of 13, and that does not equal 5. So that, I'm just demonstrating to you, is not correct. So what is correct here is that if I have the square root of a squared quantity, x plus 3 squared, that does equal x plus 3. But let's explore what that means. That means x squared plus 6x plus 9 is actually a perfect square, and I could rewrite that as x plus 3 all squared, and because it's a perfect square, I can then say that that equals x plus 3. And notice, x plus 3 squared does not equal x squared plus 9. Another error I see a lot is if I'm asked to find x squared when x is a negative number like -2, often see x squared equals -4. Well, that is incorrect. I have to square x. So in this case, I would have to say -2 squared, which of course is -2 multiplied by -2, which is +4. Any even power will result in a positive number. So you've got to be very careful that -x squared does not equal -x squared. So you've got to be really careful about that. Know the difference between an expression and an equation. X plus 5 all divided by x squared plus 10x plus 25 is an expression. There's no equal sign to begin with. I'm not trying to solve for x. I'm just given an expression. The best I could do here would be to simplify. So if you see an instruction like simplify, you're probably starting with an expression and you might be able to get it into simpler terms. Now, this x plus 5 divided by 3 equals 10 is an equation, and you're able to solve an equation, assuming it's a true equation. So I can get a single answer for x or a series or a set of answers for x, but I can solve it. Make sure you know whether you have to simplify in the case of an expression or solve in the case of an equation. So if I have a problem like simplify, I would have x plus 5, and in the denominator there I would notice, oh, I can simplify that. It's actually x plus 5 all squared, and that is going to be, well, it's x plus 5, I don't want to make one of the earlier mistakes I talked about, plus x over x plus 5 all over 1 over x plus 5. So I notice that's a 1. So that equals 1 over x plus 5. And that is actually correct. I can simplify that expression. So here's another simplify problem. And in this one, x squared plus 10x plus 25 in the numerator and x plus 5 in the denominator, well, actually, that's going to be x plus 5 in the numerator divided by x plus 5 in the denominator. And that's just going to give me x plus 5, because really, if you think about it, this one equals x plus 5 multiplied by x plus 5, all divided by x plus 5, and this is just 1. Now, a lot of times what I see students do now is they're like, well, oh, I'm in a panic, I've got to do something, I've got to solve this. So they'll just decide it's equal to 0, and then they'll tell me x equals -5. You can't do that. This was not a solve problem, it's a simplify problem. Don't make it more complicated. If it's simplified, that's all you can do is write it in its simplest terms. You can't solve it. Now this problem says solve, and it begins with an equal sign. So I do expect to get an x equals something or other at the end of it. Of course, if I multiply both sides of x plus 5 divided by 3 equals 10, if I multiply both sides by 3, I'll get x plus 5 equals 30, x equals 25. And that's what I expect. This is an equation. This is the solution to the equation. I'm able to check, does that actually work? Notice in the simplify problem, I couldn't go back and check because there's nothing to check. So here, is it true that 25 plus 5 in the numerator divided by 3, that's 30 divided by 3, and that does equal 10, so it does check. So I expected to get a solution here because it says solve and because it's an equation.